Welcome to Brain Vision.
We need to find the speed of the bullet. Let's first write down all of our givens. We have a mass of the bullet, so 7.87 grams. This is going to equal 0.00787 kilograms. And then we can say capital M is the mass of the block, so this will be 4.148 kilograms. And then the spring constant of the rifle is 162.7 newtons per meter, and X is going to be equal to 9.46 centimeters, or we'd say, 0.0946 meters. So at this point, we should say, we can use the law of conservation of momentum and say that momentum initial equals momentum final. So we can say that mv initial is going to be equal to m plus capital mv final. So we can simply solve for v final and say v final is going to be equal to mv initial divided by m plus m. At this point, we can say that the kinetic energy initial is going to be equal to the potential energy stored within the spring. So we can say that 1/2 of m plus m v final squared is going to equal 1/2 kx squared. We're going to solve for first we should probably substitute this v final into here, so we can say this is going to equal 1/2 m plus m mv initial divided by m plus m squared equals 1/2 kx squared. So at this point, after algebraic manipulation, we can say that velocity initial equals, here it's going to be x times k divided by m. So it'll be x times the square root of the spring constant times the combined mass divided by the mass of the bullet. And here, this is going to be 0.0946 times the square root of 162.7 times 0.00787 plus 4.148. There we go. Divided by the mass, so the mass of the bullet, so 0.00787. And we find that the initial velocity of the bullet is going to be equal to 312.6 meters per second. So this will be our final answer. That's the end of the solution. Thank you for watching.